All right, 9-7 practice. Let's scroll down here and get started. Number one, so we're trying to find the area, and it says we are going to round to the nearest tenth. So there's a couple different ways you could break this one up. I would probably break it up right here, and I'm going to focus on doing the rectangle plus this triangle down here at the bottom. So you need to know the formulas for those. So remember, rectangle is base times height, and triangle is 1/2 base times height. So for the rectangle, we're looking at 17 by 10. All right, so that's how much that guy is. So 17 times 10, looking at 170. And now for the triangle, we're going to assume that this is a right triangle right here. We'll assume that's a right angle. And a right triangle is 1/2 base times height. And it looks like, let's see, if this is 13 down here at the bottom, and the top was 17, that means that this piece over here is going to be 4. And so we have that side, and it looks like we're going to need to get this side right here, which we don't have, but we can do Pythagorean theorem. So let's just call it x. And so we're going to do x squared plus 4 squared equals 7 squared. X squared plus 16 is 49 minus minus. X squared equals 33. And so x is going to be the square root of 33, which let's just bust that out real quick. So second square root 33. It's about 5.74. So when we look right here, 1/2 base times height, we're going to have 1/2 times, and we'll call this the base. And then this spot that we just found here is going to be the height. So this 5.74, blah, 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 blah. So I'm going to just punch it in. I'm going to go 1/2 times 4. And then instead of rounding that number off, I'm going to use the answer key. So I'm going to hit second negative, and that'll bring that previous answer down. And we're looking at 11.48. So that's the triangle. So now we need to add that to the 170 for the rectangle. And final answer is 181.5. So 181.5 for that one right there. That was a little bit tricky trying to find that height. All right, next one. This one looks pretty straightforward. You could break it up a couple different ways. Some people might break it up this way. Somebody else might break it up that way. So kind of up to you. I'm going to break it up this way. And so we'll basically have two little rectangles to figure out. First of all, we need some missing dimensions. Right here we have 13 by 13. So we have this entire square. So 13 times 13 is 169 base times height. And then for this other one, it's 7, but we're missing the height, so we're going to have to calculate that. But I think if I add up and I kind of add this 13 here, and actually we're trying to figure this part out. That's what we need. And since this whole thing is 13, and then we take away this 5, that's going to leave us with 8 right here. And so 8 times 7 is 56. So now we just got to add 169 and 56, which I believe is going to be 225 for number 2. All right, number 3, we're trying to find the shaded area. My big strategy, what I think we can do, if we find the area of this whole rectangle, that's going to be too big. That would be everything. So I'm going to try to do rectangle, subtract out the 2 circles. So that's my overall idea. If I find the rectangle, subtract the two circles, I should get the shaded area, which is the leftover. So I'm just going to put shaded to kind of have our setup. All right, so first things first, this rectangle is 4 by 3. So base times height, 4 times 3 is 12. Now, two circles, or remember, two circles would be 2, and the area of a circle is pi r squared. All right, so we're going to have two circles times pi, and now we got to get the radius. All right, so how in the world can we get the radius of this circle? Well, one radius would be right there, and this would be another radius, and this would be another radius, and this would be another radius. So basically, 4 radiuses make up this distance of 4, which tells me that each radius has to be 1. 1, 1, 1, 1 will give me 4. So the radius is going to be 1, and now we need to kind of crank this out. So we have 12, take away 1 squared is 1, 1 times 2 is 2. So 12 minus 2 pi would be the exact answer. Let's go ahead and let's get a decimal for it. 12 take away 2 pi. About 5.7. So 5.7 is going to be that shaded area. All right, moving down to number 4. You know, lots of different ways to do this. The way I'm going to do it is I'm going to do this entire rectangle. All right, so I'm going to do the entire rectangle, and then I'm going to subtract 4 of those triangles there. So I'm going to minus 4 triangles. So formula-wise, we're looking at base times height, take away 4, and every triangle is 1/2 base times height. So we got to get some numbers to fill in here. Well, for the rectangle, it looks like the base is 18. So it looks like, and that 18 is kind of hard to tell. I'm going to assume that it goes the whole distance. You may have looked at it and assumed it was right here, which, you know, I guess I'd have to accept that answer. But let's just go through and let's pretend 18 was the full thing. So I'm going to go 18. Whoop, make it stick here. 18 times the height is 8. And then take away. Now each triangle, so there's 4 of them, times 1/2 times, well, the base of the triangle is 4. And the height of the triangle is 4. Because remember, the base and height meet at 90 degrees there. So there we go. Now I just got to crunch all this in. So 18 times 8, that's 80 and 64, which is $1.44. Subtract. 4 times 4 is 16, times 4 is 64. Chop that in half. Means you're going to take away 32 for the triangles. So final answer, 144 minus 32. Looks like it's going to be 112. Will be the final answer there for number 4. All right, number 5. Again, I want the shaded area. So I think I'm going to do the square, take away the 4 circles. And the square is 10 by 10, because that's the base and that's the height. And 4 circles would be 4 pi r squareds. So that's going to be 100 minus 4 pi. And it looks like each radius is 2. So doing order of operations, 2 squared is 4. 4 times 4 is 16. So exact answer would be 100 minus 16 pi. But let's get an approximation for that. So 100 subtract 16 pi. Bam! 49.7 is what we're going to call the shaded area for number 5. All right. Number 6. This one looks pretty straightforward and friendly with shapes. Basically, we're going to do the blue rectangle, which would be too big. That would be everything. But then we need to cut out this red rectangle. So we're going to do blue minus red. And the blue is 15 by 9. And the red one is 9 by 3. And that gives us, what, 90 and 45, 135. Take away 27, leaves us with $1.08. Number 7, this one, my strategy is going to be, I'm going to do the square, and then I'm going to take away or subtract this circle. Now for a circle we need the radius, which shouldn't be too bad because that's halfway across, so it should be half of the 10, so it should be 5. So here we go. We're going to do 10 times 10, that's the square, and then take away pi times the radius squared. So we're at 100 subtract 25 pi. And if we want the exact answer, 100 subtract 25 pi. 21.5 when we round it up. So 21.5. Correct answer for number 7. Number 8. The big shape on the outside is the circle. And then we're going to take away from that circle this square inside here, which is going to be a little bit tricky. So those are our two shapes we're going to mess around with. Let me kind of erase this and see what we can do. So first of all, the circle. If 8 is all the way across, that means this radius here is going to be 4. So my circle is going to be pi r squared. And then we need to take away the square. All right. Well, the square, all we really have right now is we have the diagonal is 8. So two different ways to do it. The long way would be to use Pythagorean theorem. Since it's a square, we know it's something by something and they're the same. So we could do Pythagorean theorem and say, you know, x squared plus x squared equals 8 squared, and we could solve that. We'd have, I'm going to kind of write it over here, 2x squared equals 64. Divide both sides by 2. We get x squared equals 32. Then we'd have to square root both sides. Another way we could do it is, since a square is a special right triangle, it's a 45, 45, 90. To go backwards, you just do 8 divided by radical 2. So 8 divided by radical 2. These two should give us the same exact answer. Let's just verify that. So square root 32, 5.65. And then if we do 8 divided by the square root, let's just clear this out, 8 divided by square root of 2, 5.65. So you get the same answer either way. So we have 16, because 4 squared is 16, 16 pi minus radical 32. So this would be exact. But let's just get this into a decimal. 16 pi subtract radical 32. Bam. 44.6 is the shaded area. All right, last two, number 9. Looking at my basic shapes here, I want those two triangles. Couple different ways we could go about that. we could just find the area of the two triangles. We also could do a trapezoid minus a rectangle. I think I'm just going to go after the triangles here, because if I look at this, this top part is 14 and this bottom part is 20. So that's a difference of 6. And I need to split that up between these two triangles. And really, I don't really need to know which one's which, but the way it looks, I'm going to go 3 and 3 down here in the bottom. I think that will give me 20 and match up with the top. So now I have a base of 3 and I have a height of 12. So remember, the area of one triangle is 1/2 base times height. But then we remember we have 2 of them, because we have this one over here as well. So 2 times 1/2 is 1. 3 times 12 is 36. So I believe those two are 36. Now you might want to try it and do the trapezoid minus the rectangle and see what you get that way. Should get the same answer. I'll just do it really quick. If we average the two bases, divided by 2, times it by the height, and then we are going to take away this 14 by 12 on the inside. Well, 14 plus 20 is 34, divided by 2 is 17. 17 times 12, that's what, 170 and 34, that's 204. Take away 14 times 12 is 140 and 28. What's that, 168? And subtract those two, we do get 36. So it worked either way, whether I did trapezoid minus rectangle, or whether I just did the two triangles separately. All right, finally, number 10. This one's a little bit tricky because there's 3 circles going on. So I think if I do the big, well, actually, I don't even need to do that big outer circle. If I want the shaded area, I think I could just do, this circle would give me everything, but I want to take out this little guy, and I'll kind of have that donut shape. So I'm going to do the blue circle, take away the red circle, and that should be the shaded area. So the red circle has a radius of 1 in there. So this would be pi times 1 squared. And the blue circle, a little bit trickier, but the blue circle is, it's 1 plus 2 more. So that would be a grand total of 3 for the blue. So this is pi times r squared. So basically we're looking at 9 pi minus 1 pi, which would be 8 pi. So there's the exact answer. If we want to get the approximation, bust that out for you. Boom. 25.13. All right, well, hopefully at the end of this lesson you have a better idea of finding shaded areas and irregular and composite areas by kind of adding and subtracting a bunch of shapes together. See you.